So one thing, Victor, don't either hand back hosting to me before you shut down the call, or wait till everybody's out. Probably best if you just hand it over.
I'll give it back to you.
Okay. So I'm going to go make host. Okay, done. Okay, so you are now the host. So keep an eye on the attendees because we have other people who need to join. Mr. Hangabelt specifically. Looks like everybody's here. What I'd like to try while we're waiting, why don't you guys try switching over to screen sharing? Oh no, do you have to take over? I don't know, try that. Oh, there's Mr. Hangabelt, he's here. So Victor, switch over to the attendees and invite make him a panelist.
Oh yeah.
All right. Live stream. View the event.
Hello, how is everyone? We're doing okay?
Pretty good.
Good, good. Sorry, I'll turn on my thing too. Sorry, I'm in the middle of crushing a video for for the math thing.
Oh yeah.
And dinner is happening as well, but we're all good. Are you flying your colors? You are. Hold on. I can do that too.
All right. So Titan.net.
Oh, brand loyalty.
Yeah, that's a good question. What do you get? What's the clothing for tomorrow there, guys?
Oh, well, black is a very slimming look is something that I know. That's what they say. And I'm probably also, just from the standpoint of simplifying my background, because I know that it's the Darth Vader effect, I'm going to do this.
All right. So I'm going to do one more thing. So theoretically, we have, so if you guys have the ability to open up, I've got the live streams running.
Oh, do you?
Yeah, we're not recording, but I just have them up and running already. Templeton.org/
I see you found yourself a nice white wall, Ambu. That's great.
Yeah, gotta keep it professional.
Oh, totally.
Live presentations.
I work it out. I got it out. I haven't done any of the regular stretching thing that I would do.
Oh, cool. So it's running. Oh, yeah, it is going.
Carl, it'd be nice if we could do it like they have at the conferences, where the guy like runs up on stage and then runs across, you know what I mean? And they got the microphone. Hello. That'd be great. I think you'd have to wear a GoPro maybe.
Yes, I think so. All right. So everybody's here. Good. I'm going to turn off my video. Okay. Okay, so we're streaming on all 3 channels by the look of it, which is good.
Oh, look how white and boring that background is.
There we go.
That's pretty white and boring. Got a little lamp in there.
All right. Yeah, it's good. It's working. Okay, so you guys each want to try turning on your mics and saying hello, and we'll see what shows up on the stream.
Hello.
Okay.
I like how you're in the cupola there, Victor.
Hello.
Kupla.
Copla. Where did Janzi go?
Unmuted, just say you. Okay.
Ah, he's back. Anyways, I don't know. Did he disappear?
So when I turn my mic off, I drop out of the view, which is what I want, right? Because I don't want to pull. I'm trying to make sure that everybody's feed shows up on the live stream. And if I've got my thing on, then
Before we kick this off, everyone is present. We've all got microphones that work. We've all got video that works. It looks like everyone's got backgrounds more or less laid out. How do we want to roll through this? Like, what's the goal? We're doing a dress rehearsal, so I'm not trying to be asinine. But what are we trying to accomplish in the next whatever half hour?
I think we want to do beginning to end.
Oh, okay.
So, and I can be Mr. Morani.
Yes, I haven't received anything from him in the way of video. I mean, if in the end he's not a part of it, that's how it is, and that's fine. And maybe he's a busy guy. I don't know. And so then I guess the idea is to time it then, Janzi, also?
Yeah, because then we'll have an idea of how long it's going to take. So do you have both the, just play what's his name's video twice, I guess. Or no, we'll just.
No, I have stuff that I can put in place.
Okay.
It'll just be a placeholder. It's fine. Like I said, I've got about 25 minutes of conversation from today that I have to still snip and cut and try to put together.
Exactly. Yeah.
It's a bit of a gong show, but I will get it done.
Yeah. All right. I'm trying to think of if I've missed anything. So I have enabled screen sharing for everybody.
Okay. Yeah. Sorry. And then Janzi, just to make sure that we have this together before we get going, I can close Teams. Can we be clear about the responsibilities? Like who is one of the issues that came up when we were doing this before was that it was not entirely clear who was going to be turning on screens and turning off screens.
Right.
So is there any responsibility for me or anyone else to like turn screens on and off, or is
let's go with Victor will turn your screen on and off.
And okay, so the other issue that
works, right, Victor? Can you do that, or is that
not on?
Not on.
So and we have to talk about two different things. There's video sharing and then there's screen sharing.
Yes.
So you can turn screens on video. You can turn video sharing on and off. True.
I can ask to turn it on.
I see. And you can't do screen sharing.
No.
Okay, fair enough. So users are responsible for doing that themselves.
Yeah.
And then the other thing I wanted to point out is that if you have a video or have something that I think it's my responsibility or whoever's responsibility to turn on the mute as well, right? Like to unmute it, because last time we played a video and there was no sound. Is that fair?
Yeah.
Okay. My suggestion then is going to be just to like count to 10 and just take the time to do it. And if it's a little bit awkward and it's like, hey, is this working? I think that's okay. I think it's better than playing stuff with it muted.
Yeah.
Okay, well, do we need anything else before we get going?
No.
So for passing on the videos, if you can do it a little bit earlier, I think last time we kind of did it like you introduced us and then did it. But that kind of just made it confusing for if we're actually deciding whether we're going to turn it on or if it's you doing it. So just
let's
do it like
go
a little
with
bit early.
Victor will prompt you to turn on your video and your audio, and then he'll introduce you. Okay, and then you can say the thing you want to say, and then start your presentation, and then go into your presentation from there. So so it's kind of like the chit chat back and forth, and then launch your presentation. Okay,
Sure.
and that will give me a time to adjust the view on my screen to show your presenter on half the screen and the presenter on half and the presentation on half. Yeah. Okay.
Sounds good. And also, did we work out the sizing stuff with the?
That's what I'm going to try and figure out.
Okay, gotcha.
Working. The short answer is I don't think we have any control over that.
Yeah. Okay. Well, I'm ready.
Okay. Are you guys all ready?
And are we starting with the slideshow?
We could. I just have to go get it. That's all. Just give me a second. Yes, we might as well start with that because that's a good question. Who's actually going to run the slideshow? why don't, yes. I could run the slideshow, I think.
We just need a couple of minutes, right? Just to kind of get that, so we have that rhythm, and then we might even hit it right on 7 o'clock. We can run a 2-minute slideshow and let that bad boy get going.
All right. Talks. I just got to grab the pre-show, and it's a movie, right? Is that what it is?
Yeah, it's an MP4.
MP4. And TEMP Talks 2020 Export 1. It is 3 gigabytes. It's a 3 gigabyte video. What the heck? Holy smokes. So I've just hit 300 megabytes. So 10 times as long as we've just waited. Okay, let me just try to see if I can share it right from Chrome. Okay, so to do that, I would go screen share, files, Google Drive, of course. And see how long it takes, which is going to be faster. I'm a sixth of the way through. No, I see I can't because I don't have access to shared drives from here. Okay, so let's go without the video then.
Okay, and I guess we have to sort that out, right?
Yes, exactly.
All right, fair enough.
All right, so Victor, what you can do then is you can be as if it just ended, right? So you can, so everybody should have their video off.
We're all screens off right now?
All screens off.
All right.
I'm going to mute you too, Janzi.
Yep.
Okay, and 3, 2, 1, action. Good evening, everybody. Thank you for tuning in to TEMP Talks 2020 online edition in the comfort of your own home. I'm Victor Leung, and I'll be your hostess with the mostest for this evening, live from the cupola of the International Space Station. I'll be graduating in about a week now from Templeton, and I'll be moving on to UBC in the fall. TEMP Talks has been a STEM annual tradition where students get to share their favorite learning experiences with a live audience, and where those audience members eventually get to move to the Templeton cafeteria and do a gallery walk where other STEM students have positioned their projects and get to share their experiences with the members as well. But unfortunately, that was not doable this year, of course, during these unprecedented times, but we will press on. And of course, I'd like to thank the students, Hengewald and Janzi, for wanting to continue the tradition in our web format. Tonight, as promised, we have 5 main stage presentations. We have 3 presenters that will be joining us live, and we have 2 video presenters who have pre-recorded a short presentation. Of course, I'll go through the little menu of tonight. So up first, we have a live presentation from Sam and Elliot. They'll be talking about their SlamBot, but also sort of the teamwork and the relationships that they've built through their project work. Following that, we have a video that's been made by Mercedes and Isabel, 2 girls in STEM 9. They'll be talking about their passions and successes in math. After that, we have Ambu in STEM 10. She'll be talking about STEM 10's sort of overarching green theme of the year with their projects, but also the interdisciplinary nature of STEM and how the borders of the STEM topics are frequently crossed. Again, following that, we have another video from Max. He's in STEM 10. He'll be talking about his capstone submarine, how he's been able to pursue his passion and to build an RC submarine that's been enabled through sort of the STEM program. And last but definitely not least, we have Tyler in STEM 12. He'll be talking about sort of the lifelong modern day skills that he's learned in the STEM program and how that's translated into his SAP internship last summer. And now he will translate those skills into any future workplaces. And of course, to end off the evening, like I said before, we have students from across the STEM cohorts curate a gallery of videos that we've all put into one website, and we will give the link to those at the very end. I do hope you stay tuned for that. Thank you for listening to me. Now I will end the screen for myself, and I would cordially like to invite Templeton's principal, Raza Marani, to the screen, and then our program coordinator, Mike Kengeveld, to say a few words as well. Mr. Marani.
Hello, everybody. It's wonderful to see you here tonight. Thank you so much for coming. And as you can see, we have a fantastic lineup of presentations and videos tonight. Really looking forward to having you engage with us and enjoy the time together. And hope you will really be able to take from this presentations tonight the amount of work and time that these students have obviously put into both their learning and then showing you, reflecting on and showing you what that means to them. So again, thank you very much, Victor.
Thank you, Mr. Marani, for the kind words. And again, as promised, our program coordinator, Mike Kengeveld. Mr. Kengeveld?
Okay, I'm hoping you can hear me, Victor.
We can hear you well.
Hello, my name is Mike Hangeveld. I'm the program coordinator for the Templeton STEM initiative over in East Vancouver, and I'm so glad that you can all come out and share in this. This is easily my favorite part of every year, and it's marked really by being the place where we hear student voices instead of teachers' voices, which is always a joy. And sometimes it's hard to get students to say things, so this is always my favorite to watch students share their learning. One of the questions that we ask as staff members when we design things and we talk about how to shape the project-based learning is, who owns the learning, right? And that's a central question for us. And I really hope that comes through today, because what we find is that if you have students at the center of their learning, you see amazing things. I really hope that shines through in the presentations that we see and in the gallery offerings. The kids are really doing pretty amazing things. And I guess I would be remiss if I was to not mention that the other amazing teachers in the program that have been working with us, Mr. Carl Janzi, who is with ADST and as all thing tech and computers, Mr. Kyle Renwick, another physicist, who is working in with the STEM 9 cohorts, and Ms. Ravinder Kar, who is also working with the STEM 9 cohorts. It really is a group effort. So enjoy the evening, and back to you, Victor.
Thank you again, Mr. Hengeveld, and we are always gracious of your presence. Okay, so let's move on to tonight's specials. Up first, again, Sam and Elliot. I've heard of fraternal twins. I've heard of biological twins even, but rarely have I heard of a more complementary duo than the Wonder Twins. Sam and Elliot, who are here with us live this evening and will happily share their slam bot with you. The screen is yours, guys.
All right. So hello, everybody. My name is Sam.
And I'm Elliot.
And today we're going to be talking about our project. So let's get started. So in recent years, humans have progressed artificial intelligence and technology to a point where many tasks and jobs have been filled by machines. But how can two high school students take advantage of this technology? We want to know how we could engage with the field of automation and build our own autonomous project using the components and resources available to us. And how could we apply what we've learned from this project in the real world?
So I'm Elliot. I'm the engineering lead for this project and a grade 12 STEM student this year.
And I'm Sam. I am the coding lead for this project, and I'm also in grade 12.
So before we talk about our solution to automation, here are some examples of jobs that have already been tackled by other systems. You probably already use some kind of machine learning today. For example, Google Maps, which uses machine learning for navigation, or YouTube and Netflix, which learn about your preferences to suggest the best media for you, or even Facebook, which recognizes your face to group photos of you together. Many other social media services also use artificial intelligence to optimize the user experience. Automation and machine learning is also applied heavily in autonomous cars, like Tesla's. Slambot is our version of an autonomous vehicle. It can create a map of its surroundings and track where it is in space. We designed our platform to be as versatile and easy to adjust as possible to make the prototyping stage as efficient as it could be. The goal of this project was to create a robot which we can give a destination and have it navigate its surroundings to this waypoint. This was designed to be a proof of concept for automated delivery, as it could be used to deliver packages to specific destinations without the need for human intervention. Vehicular automation is one of the most versatile types of automation, as it can be applied to many situations. If you have a robot that can not only complete a task, but understand where it is in space and where it needs to go to complete said task, it opens up a whole range of possibilities for automation. Why is our platform so flexible? The brain of our robot is a Raspberry Pi 4, which is a full desktop computer the size of a credit card. The main sensor on the top is the LiDAR, which stands for Light Detection and Ranging Sensor. The LiDAR uses a laser that spins 360 degrees and bounces off any nearby surfaces, and then is received by the sensor in the LiDAR. The distance is then calculated by using the time it takes for the laser to bounce back into the sensor. If you've ever seen a virtual house tour, this was created using the same sensor technology. Slambot makes use of ROS, Robot Operating Systems, which uses a variety of libraries related to robotics and automation.
So right off the bat, we have a short video to show you. And so what's going on here is the Slambot is running a predetermined path, and it is mapping as it goes along. So we'll get into more depth about what's actually running, what software the robot is actually running right now, and how it's actually doing that in the mapping. All right. So the coding aspect of this project involves many processes which have to work together. Most of these are handled by the ROS, which we are running on the Raspberry Pi. One of the most important algorithms is called SLAM, or Simultaneous Localization and Mapping, hence the name Slambot. This algorithm converts LiDAR data into a map by identifying new and already scanned points. When these points are considered and the new and old ones are combined, the map is created. This algorithm has some limitations though, but it can create maps if we consider these things. The reason why we need to use SLAM in conjunction with the LiDAR is because the LiDAR data is static. The LiDAR is almost like the robot's vision, and the SLAM is like its memory. So as you can see here on the left, the raw LiDAR data just scans new points and the old ones disappear. But once it's processed by the algorithm, as you can see on the right, it can actually use those points to create an accurate map. Once this map is created, we can use ROS to generate route plans and identify where the robot is. This is the next step for our robot. The SLAM library we were using prior to ROS was called Breezy SLAM by Simon Levy. This is a really great library because it's so simple, though it's a bit unreliable in times and it's not very intuitive for adding our own code. So that's the library that was actually running in the video that we showed before.
One of the most important aspects of this project was our prospects for real-world application. There are many situations where the same technology could be used for an actual occupation if we scale up our robot. Since it can map almost any indoor surroundings, it's very versatile. Our project is a proof of concept that can be applied, for example, to package delivery robots, autonomous indoor mapping, or even for use in emergency scenarios where it's too dangerous for a person, for example, to survey a damaged building after an earthquake. Though our robot is on a smaller scale, and it may not have a wide range of features, many robots currently in production, such as these ones shown here from Boston Dynamics, use very similar technology and concepts. Notice the LiDAR sensor on both of these robots.
So this project involves many convoluted elements which have to work together to form the final product. We believe we need to invest a lot more time into understanding these elements to continue to a final point, as we ran into several roadblocks which left us stuck. The first was the limitations of our original computer, the Raspberry Pi 3. It did not have enough processing power to run the SLAM software, and the maps that we generated weren't usable. We had to upgrade to the Raspberry Pi 4, which was much more powerful, to generate working maps and run the other processes. The most fundamental aspect of this project was coding. This provided possibly the greatest engineering challenge in our STEM careers, as we had to apply some incredibly complex concepts, including machine learning, algorithms, and operating systems. We eventually decided to try to use robot operating systems, which combined almost everything that we need into one part of the project. Though this sounds convenient, it is an incredibly extensive topic and has a really steep learning curve. For this reason, we require much more time to be put into programming and learning about ROS to fully complete our robot. Switching to ROS also meant we had to scrap the code that we had and the libraries that we were using beforehand. Though we didn't quite get every part of our project working, we learned a vast amount and gained many skills which we can apply in many different situations.
Since this project combines so many different topics and aspects of engineering, we got to apply a lot of what we've learned from previous projects and learn a lot more about many concepts. Both of us are part of the first robotics team at our school, so this project was a great way for us to apply what we've learned through the robotics club as well, especially with 3D modeling. We gained a lot of experience with Python and other languages and got to go really in depth to apply these algorithms and software needed to complete the project. Even though we didn't reach our final goals, we gained a lot from working on something so advanced. Overall, this project has been a huge learning experience, and it was very engaging to work on something so complex.
So this project has a great amount of potential and only needs a little bit more work to have a finished prototype. So to achieve our goals, we'll need to go very in depth with ROS and learn a lot more about coding in that environment. Once we have gotten comfortable with that, we will be able to use the maps generated by the SLAM bot to identify its position and allow it to navigate to its desired destination. We have also come up with many other stretch goals over the course of this project, including stair climbing, QR code recognition to identify package destinations, autonomous mapping so that we don't need to create a map manually, and many other features to make this project truly autonomous. So thank you very much for watching.
Thank you, Wonder Twins, for sharing that with us. I'm glad you could take the time out of your evening and to join us live.
Thank you very much.
Thank you, guys. And up next, we have two STEMers that might be better than me at math. The STEM 9 math magicians, Mercedes and Isabel, with their video showcasing their learnings in math and their passion about math. thank you. Thank you. A very intentional and direct video. And of course, I'd like to thank Isabel and Mercedes for putting their effort into it. Now, I'd like to share with you all a STEMmer trying to save the world by learning all things STEM. Ambu, I'd like to invite you to the screen, and you can take it away.
Hello.
Hello, how are you?
I'm very good. How are you doing?
I'm happy to hear that. I'm good as well. I hear you have a
Great.
presentation for us.
I do have a presentation, and I will share that right now. Okay, and here we go. Hello, everyone. My name is Ombuanse, and I'm in grade 10, and I've been in the STEM program for 3 years. Some of you may know that STEM stands for 4 different disciplines: science, technology, engineering, and mathematics. But how do those fit together? Let's take a look at 2 examples of projects this year. I will briefly explain how each discipline fits into the aquaponics project and our passive house project. So the first project I'd like to talk about is aquaponics. Aquaponics is a system for combining aquatic creatures and hydroponics, which is a method of growing plants without soil in a sustainable way. Our current agricultural practices need improvement, and aquaponics is one way to do that. So let's talk about the science of aquaponics. A key factor to understanding aquaponics is the nitrogen cycle. Fish need nitrogen as it is their protein, and like us, they need it to survive. They intake the nitrogen by eating their food and then excrete it via their waste in the form of ammonia. This ammonia makes the water acidic, and if it builds up, it is unfortunately deadly to the fish. So the solution to this problem is plants, as they are able to essentially filter out the water. They absorb the nitrogen, but they can't absorb it in the form of ammonia. So that's why, as part of a 3-step process, different bacteria convert the ammonia into nitrites and then into nitrates, as you can see in this chart. Once the nitrogen is in the form of nitrates, then the plants can use it as their fertilizer, filter out that ammonia, and leave the water fresh and clean and leave the fish safe. Now, another issue addressed in aquaponics system is pH levels. We need to know chemistry in order to solve this. Fish thrive in a certain pH level that isn't too acidic from the ammonia. We realized that we would have to monitor and adjust the pH levels every single day, but who would want that time-consuming task? So we asked ourselves, is it possible to automate the system? Here's where we went to technology for a solution. We designed and made an automated pH monitoring device. This involved programming and wiring the pH monitor, as well as recording the data. Now, where did math come up in this project? We did a lot of mathematical modeling in the design of our system. What size pump and heater do we need? What rate should we feed the fish? How do we right-size the number of plants to filter the water? This math was integral for our project to function. Now that's how our aquaponics system fits together and how each subject or discipline is crucial. The disciplines all have their part in creating this system. As Aristotle said, the whole is greater than the sum of its parts. What I've learned in the past 3 years is that these disciplines are always interconnected in real-world applications. In fact, it's really only in theory when you can try to isolate them from each other. Connecting these topics is logical and effective. Okay, let's look at another example. This is the Passive House project. Climate change is real, and it's a huge issue. We all know that. How can we as individuals make a difference? We need to do a better job of heating and insulating our homes. The truth is, Vancouver's standard of insulation is extremely low, and most people use gas to heat their homes. Can we design homes that leak less heat as well as use solar power to offset gas? Now, where's the science in this project? Thermodynamics is the branch of science relating to heat. There are 3 kinds of heat transfer: conduction, convection, and radiation. We use these theories to model and design our experiment. For our actual experiment, we constructed 2 small model homes out of rigid insulation to demonstrate the difference between high and low values of insulation. As you can see here, we called them the Passive House and the Vancouver Special. Now, how can we use technology to run our experiment? We had heaters in both the houses, but how do we build a thermostat? How do we monitor the energy use of both homes? We used an array of solar panels to power the houses, but how do we control that flow of energy? This gave us a chance to learn how to wire solar panels, how to properly construct the houses, as well as how to program temperature sensors and heaters. Now, did we need math for any of this? Throughout the project, we were always doing calculations and estimates. For example, can we predict how much heat these houses will lose? How many solar panels are required to keep up with that? Statistically, how much solar radiation can we expect in Vancouver, and how many batteries will it take to store it for when we need it? We used the heat loss equation to calculate the heat loss and determined that we would need an array of 8 solar panels. Now, these are just 2 examples of many projects we've done throughout the years in STEM. This format allows us to learn the skills, but most importantly, apply them. I'm aware how applying skills, project management, and troubleshooting are all abilities I got in STEM, but I can now use in my everyday life, not just in school. For me, these projects are a really fun and exciting way to combine the disciplines, as well as learn so many new things. It's really amazing to see the final product and how everything works together. I'm so beyond happy that I chose to join STEM. This probably sounds like an advertisement, but honestly, I really think it's a perfect fit for me, and I really enjoy coming to school. I'd like to finish with a quote from the French mathematician Henri Poincaré, which I think applies to this. Science is built up of facts, as a house is built of stones, but an accumulation of facts is no more a science than a heap of stones is a house. STEM combines these 4 disciplines because they work better together. Thank you so much to everyone who took time out of their day to come watch our presentations. I hope everyone is doing well. Thank you.
Thank you, Ambu. And I do feel a lot more educated after that. So I want to thank you again for putting the time into your presentation.
Thank you very much.
All right. And for our next presenter, this is another pre-recorded presentation. It's going to be a video from Max. He's in STEM 10. There we go. Video's ready to go. Here it is, as promised. Max is passionately trying to reach and study the ocean floor with his capstone submarine.
Look a little bit like an H. One half is dedicated to the motors and electronics, and the other half is dedicated to. Hey, I'm Maxwell. I'm in and throughout this school year, I've been making myself. Ever since I was little, I've always been into RC vehicles, but I've never actually had an RC submarine before. Over the years, I've accumulated a ridiculous amount of spare parts and RC equipment, and I kind of want to use it all up. I've been doing that during capstone projects in the STEM program, and for 3 years, I've made 2 planes and now 1 submarine. We do capstone projects in STEM at the end of each year, so you can use all of the knowledge you've gained that year to make a really good project of your own. This year was actually an exception, as we worked on the capstone periodically throughout the year. I'm glad that we could take more time and I could choose more projects. The submarine is made out of 2 sewage pipes and a T connector, which makes it look a little bit like an H. One half is dedicated to the motors and electronics, and the other half is dedicated to the ballast. A linear actuator moves pistons, which fills the bottom half of the submarine with water, which can make it sink, and then it can push the water back out, which makes it lighter and float again. One of the challenges that comes with building an RC submarine is that RC signals and Wi-Fi both don't really go through water very well. If I was trying to use a wireless connection, when I dive below the surface, like I am right now, usually I'd lose complete control, and I wouldn't be able to talk to the submarine anymore. To work around this, the entire submarine is on a tether, and through that tether, there's a wired connection to the RC into the depths of the deep end of Temple Pool. Originally, the test was supposed to be at Temple Pool where you can see through the water, except due to COVID-19, I had to go to Case Park instead because all of the pools closed. I think the great thing about CAPSTEM projects in general is that you learn everything about STEM, science, technology, engineering, math, in a project that you choose, you're really invested in, and it makes school just a lot more enjoyable when you're doing something that you really want to do. I had tons of fun working on this project through the year, and I'm really happy with the finished product. Thanks so much for watching.
Max has worked hard to make his project work, and I think it really did show in the video. Thank you to Max. I think he's with us tonight for your video, and I hope that you maintain your passion. Last but not least, we have STEM's very own giraffe coming in at an astonishing 6'5". Tyler will be talking about his SAP internship, the lessons learned, and the lessons to learn. Tyler?
All right. Thank you, Victor.
You're welcome.
All right. Let's see. I've got a presentation ready for everybody. Thank you so much. All right. Here we go. Okay. As Victor mentioned before, I'm going to be talking about 21st century skills. Hello, everybody. My name is Tyler Takeshi Wallace, and I am a grade 12 STEM student. Next year, I'll be going to Langara College for general sciences with hopes of transferring into environmental sciences in the future. I've been in the STEM program for 5 years now, and last year I got the incredible opportunity to be one of the 2 first ever high school aged interns to work at SAP. Now, for those of you who don't know, SAP is a software development company that specializes in business operations, customer relations, and enterprise resource planning software. Basically, in simpler terms, SAP creates software to make business management more efficient. SAP is also the beloved sponsor of the STEM program here at Templeton. And for years, they've been providing us with meaningful support and funding alongside their mentorship program, which brings SAP mentors into STEM classes to teach students all about 21st century skills, which is what I'm going to be doing today here as well. But before I go into that, I'd like to talk a little bit about my internship and the work I did last summer. As I mentioned before, I was one of the 2 high school aged interns, the other being Danielle Pebres, who is another high school STEM student from Templeton. And this was actually the first time that any high school student had been brought to work as an intern at SAP. And it was really special to be a part of, and it was only possible because of the relationship that is shared between STEM and SAP. The 2 of us were stationed at the SAP Vancouver office, which is in Yaletown. And in that office, we were put on a team called the Cloud Engineering Platform. And that team had a team lead who acted as a mentor for us and really helped us and acted as a guide throughout the internship, helping us with our project and really giving us a great taste of what a real office working environment was like, because obviously that was something that neither of us had ever experienced before at 16 years old. We also worked very closely with SAP IXP, or what is known as their Internship Experience Project, which is a mentorship program that brings interns from a bunch of different SAP offices around North America into weekly phone calls with SAP mentors. And they teach us all about 21st century skills and how to apply them in the real world. Not only was this an amazing chance for us to learn from these mentors that SAP provided, but as the youngest, as high school students, we were working with other interns who were in college or university. So it was also a great chance to get some advice and words of wisdom from them. Overall, it was a great learning experience. On top of all that, we also worked on a project that was in the SAP Vancouver office called the Employee Engagement Project, which was basically our job was to develop a system that would measure the effectiveness of events that were held at SAP Vancouver. It was a lot of work related to survey building software, data analysis, and spreadsheet work. And overall, it was just a fun and unique project and experience. So a couple times I've thrown around the term 21st century skill, so now I'm going to go into depth about what they really mean. By definition, a 21st century skill is a skill or a core competency that is believed to be required to thrive in the working world of today. Now, there's a lot of these 21st century skills, the 4 most commonly known as the 4 C's: communication, collaboration, creativity, and critical thinking. There's other ones like being able to prepare yourself and plan ahead for things or organize yourself, and so many more. And I personally think that these 21st century skills, or what are also known as soft skills, are more important than what are known as hard skills, or skills that are related to your field of work. whether that's physics or computer science or business or whatever you may be. And I'm going to use myself as an example as to why I think that. I've been in the STEM program for 5 years now. And as many of you know by now, the STEM program is a project-based learning program which brings students together into groups to work on problems and projects related to the 4 STEM fields: science, technology, engineering, and math. But what not everybody realizes right away is that while these students are working together in groups to solve problems and work on projects, they learn a lot of these 21st century skills as well, like collaboration, critical thinking, creativity, and so much more. And that's really what I realized when I was asked to go work at SAP for the summer, because I knew that I didn't have any of the hard skills that I would need to work there, like experience with data analysis or spreadsheet work or survey building, because I was 16 years old and that was something I had never done before. But I did know that I was going to have to transfer these soft skills that I had learned from STEM into my work at SAP. And it actually made the transfer from student to intern much, much smoother. I was actually pretty surprised at the beginning of my internship to find that SAP wasn't just an office building that was 3 floors full of hundreds of cubicles with people typing away 24/7. Of course, there was a little bit of that because it's a software development company, but I was also very surprised to find that there were probably near 100 different meeting rooms and workspaces that were all varying in size and different materials available. Like some rooms had smart boards or whiteboards, and other ones had walls that you could write on. It was a lot of fun to work with. And these spaces were meant for employees to come together and work in groups to solve problems and plan out their projects. Now that may sound familiar because that's exactly what STEM trains their students to do. So it was really great going into the beginning planning stages of our project at the office, where I got to apply these 21st century skills that I had learned in STEM, like collaboration and problem solving, critical thinking, organization, and so much more, into my work at SAP. Of course, during my time at SAP, I did learn those hard skills that I mentioned before, but it was really the soft skills that I built up and improved. And I think that's really valuable because now I know that these skills are transferable. So the skills that I've learned from STEM and now from SAP are going to be applicable no matter where I end up in the future, whether that's as a student in a learning environment or as an employee in a working environment. To wrap up, I really want to say that I believe these 21st century skills are very important and definitely needed to go into the working field of today. It was really the mentorships that I received from STEM and SAP that helped me realize what I needed to learn to do well in the working world of today. And I think that's really valuable. I also think it's a good representation of the STEM motto, just to fail fast and fail forward, because I'm not a perfect straight A student, and I never was, but I'm a hard worker who's willing to get out of their comfort zone, someone who's going to be ready to fall down and get back up again to learn something new. And that's what I think the STEM program is all about: being able to make mistakes, recognize those mistakes, and apply those learnings that you learn from the mistakes to whatever situation you're thrown into next. And when you repeat that process many, many times, you end up with a lot of these 21st century skills that are applicable anywhere you end up. And so to answer the question that is asked many, many times in high schools all over the world, when am I ever going to use this skill? I found myself asking this question a couple times throughout my high school career, to be honest, but never while I was in the STEM program, because I know that these skills are transferable. So it doesn't matter if I don't end up in a STEM field, because honestly, I don't know where I'm going to be in 5, 10, 15 years from now, because I know that these mentorships that I received from STEM and from SAP have given me the learnings that I need to know to go wherever I want to. These skills are more important to students now than ever before. Not only do they set students up for successful learning, but they set students up to work in a world that is constantly changing and requires constant learning as well. Believe it or not, we're living in the 21st century, and it's different than the last one. The world of today is constantly changing, with new technologies, sciences, trades, industries, and everything else in between being developed and redeveloped every year. It only makes sense to train these students to deal with that change, how to adapt to it, and how to learn from it. In life, we don't always have control of the steering wheel. Take this curveball that we've been thrown in 2020. Nobody could have seen this pandemic coming, but as a society, we've come together and adapted and all learned something new to survive. These are the skills that we're not only going to need today, but they're the skills that we're going to need when everything is different tomorrow and for the rest of our lives. Thank you very much.
Thank you, Tyler, for sharing that with us. But now, unfortunately, we do have to send you back to the zoo. The
All
cage
right.
master will be coming shortly. Just kidding. But I'm happy that you took away such valuable skills from that experience. And thank you for your hard work and dedication that helped to make this happen.
Thank you very much, Victor, for having me.
Thank you, Tyler. And wow, what a fun and a new night. The time is now 7:38. On behalf of the STEM team, I'd like to thank everyone for joining us for our annual but modified TEMP Talks. And with that said, I cordially would like to invite you all to our modified gallery walk, where all of our students have curated their most proudest moments and put that all into video format. I'll give you all the link to that now. Please feel free to click off the live screen when we're finished talking. Before I go, I'd like to invite all of the presenters back up to the stage, and we will all say our final goodbyes. Again, thank you all for tuning in. I wish luck to all my peers and to STEM students underneath me. Take care. Have a wonderful rest of your evening and a COVID-free summer. Good night.
Thank you, everybody.
Thank you. Bye.
All right, how long should we sit here awkwardly?
I don't know.
No, that was great, guys. That was great. Okay, so I'm just watching. I've been watching the stream as well.
Yeah, me too. It's awesome.
It's awesome. Yeah.
Awesome. This may be my favorite TEMP Talks yet.
You burst out laughing in the middle of stole the
And
screen.
I was like, what did I do wrong?
It's like,
Oh,
oops,
me?
forgot to mute my
You're
mic.
like, woo!
Oh, sorry.
So weird.
Sorry, me.